Okay, solutions for practice questions 5 and 6. 5a, solve the following equations. You can see for a we have x is having 5 added to it. So the inverse of that would be subtracting 5. What we do to one side we must do to the other side, so everything stays in balance. And if we had 5 on the left and we take away 5, we end up with 0, and we still have the x. And 10 minus 5 is 5. So there's your solution. X is equal to 5. For b, we have x minus 7 equals 10. So the inverse of subtracting 7 would be adding 7. And when we simplify, we end up with x on the left and 17 on the right. For c, we have 2 times x is equal to 10. So the opposite of multiplying by 2 would be dividing by 2. 2 divided by 2 is just 1, so we're left with 1x. And 10 divided by 2 is 5. For d, we have x being divided by 3. And the inverse operation to that would be multiplying by 3. So we multiply by 3 on both sides. On the left, we have 3 divided by 3, which just gives us 1. So 1x. And 10 times 3 is 30. Those are your most basic kind of one-step equations. If we look at e, we have x squared plus 5 is equal to 14. So order of operations tells us we are first going to square x, and then we add 5. So to undo these operations, we start with the last operation, which was add 5, and we do the inverse of it. So we will subtract 5 from both sides. Leaves us with x squared on the left. And 14 minus 5 would be 9. And the opposite of squaring x would be square rooting. So if we square root both sides, the square root of x squared will just leave us with x. And the square root of 9 is 3. There is something that I'm going to just throw in here that we don't need to worry about too much right now, but the true answer to this should be plus or minus 3. And I'll show you why. If we were to check our work, and we take x is equal to 3 and substitute it in, we have 3 squared plus 5 equals 14. Well, 3 squared is 9, and if we add 5 to that, we do get 14. So that's a true statement. Let's check and see what happens for negative 3. When we square negative 3, it also becomes 9. And then when we add 5, we get 14. So there's actually two possible answers here. In the unit we're working in, solving information with triangles, we're always going to be looking at measurements for distance and things like that, so it's not too much of a worry here. But that's the proper way to do it. For f, we have x being squared, and that's equal to 4 squared plus 3 squared. So if I want to isolate the variable first, x, on its own, I have to inverse the squaring, so I square root the left side and everything on the right side. So the square root of x squared is x. And now I've got this messy piece here. It's actually not too bad. Order of operations says if we're going to simplify this, we just start inside the brackets. Well, brackets, but I said brackets, but I don't mean that. We have a square root, and we kind of assume that there's brackets, or it's grouped underneath that radical sign. So 4 squared is 16, and 3 squared is 9. 16 plus 9 is 25, and the square root of 25 is plus or minus 5. Question 6. Here what we're going to do is we're not actually going to solve and get a value for our answer. We're actually just going to rearrange the equation to solve for a different value. So you can see this equation here, a times b is equal to c. If I want to solve for b, it means I want to rearrange the equation so I have b equals something at the end. So to do that, we would look at what's happening to b. Well, b is being multiplied by a. So to undo that, I would divide by a on both sides. And then I end up with b is equal to c over a. For question b, I have x plus y equals z, and I want to solve for y. So what's happening to y? Well, we're adding x to it, so let's subtract x from both sides. And y will be equal to z minus x. For c, I'm looking to solve for c, and I have c over d plus 5 is equal to e. Well, c is being divided by d, and then we're adding 5. So first I would subtract 5 from both sides. I have c over d is equal to e minus 5. And then I need to multiply by d both sides. Make sure you multiply everything on the left by d. And I have c is equal to e minus 5 times d. For d, we're going to do the same question again here, except for we're going to solve for d this time. And this one, there's a little bit of a trick to it. Because c is being divided by d, can't do too much with that right now. We're then adding 5. So if I want to get rid of this 5, I'm going to subtract 5 from both sides. Now I have c over d is equal to e minus 5. Now the value we're looking for is in the denominator. So what we actually need to do is get that out of the denominator first. And we'll multiply by d on both sides. Now we have c is equal to e minus 5 times d. But really we want to get d on its own, so we need to get rid of this e minus 5. So we can divide by e minus 5. Make sure you keep it in brackets. What we do on the right, we must also do on the left. So e minus 5. And we can see here that d is equal to c all over e minus 5. So when the unknown is in the denominator, you kind of have to use a little bit of manipulation to get it up into the numerator before you can use your pattern of inverse operations. For e, we have 2 times x plus 3 equals y, and we're looking to solve for x. So order of operations says you would be adding 3 first, and then you'd multiply by 2. So to undo those operations, we first divide by 2 on both sides. That'll leave us with x plus 3 on the left, and y over 2 on the right. And then we subtract 3 on both sides. That leaves us with x is equal to y over 2 minus 3. For f, we're looking to solve for z. So we would take the square root of both sides, because z is being squared right now. And that would leave us with z is equal to the square root of x squared plus y squared. Nothing else we can do with that question. For g, same question, except for now we're looking to solve for x. You can see that x is being squared, and then we're adding y squared to it. So we should first get rid of the y squared. We have x squared is equal to z squared minus y squared. And then I need to take the square root of both sides. So x is equal to plus or minus the square root of z squared minus y squared. And I've included this plus or minus, but it's nothing for you to worry about right now. The positive root is all that we really need. And one more time for y. y is being squared, then we're adding x squared. So let's get rid of the x squared first. Y squared is equal to z squared minus x squared. And then I need to do the square root of y squared, which leaves me with y is equal to square root of z squared minus x squared. And that is it for the equation solving piece. I'm not going to go on here through questions 7, 8, 9, and 10. I'll let you work on those on your own, and we can chat about those in class. Keep up the good work.